In this video, I'm going to discuss about vitamin B. That includes all types of vitamin B. So the first one is the vitamin B1, or known as thiamine. So this thiamine acts as a coenzyme in the metabolism of carbohydrate and is present in all living tissue. And thiamine is always available in the form of its chloride or nitrate, and its structural formula is represented by this figure. So you can see that it can exist either as chloride or nitrate. So this is the one that depends whether it can exist as a chloride salt or also nitrate salt. Small quantities of thiamine are present in almost all foods of plant and animal origin. For example, whole cereal grain, organ meat such as liver, heart, and kidney, and also can be found in eggs, nuts, and also potatoes. This table shows thiamine content of some food. So if you look at this one, the highest macaroni, enriched macaroni has the most thiamine content, while pork or also lean pork also contain lots of thiamine. Thiamine is one of the more unstable vitamins, so various food processing may considerably reduce thiamine levels. Thiamine can be destroyed by heat, oxygen, sulfur dioxide, and also neutral or alkaline pH, but light has no effect on the thiamine. At neutral or alkaline pH, the vitamin is destroyed by boiling or even by storage at room temperature. Meaning to say, for example, if you are cooking rice in distilled water, it will reduce thiamine content negligibly, meaning if you cook rice in distilled water, thiamine content will not reduce. Whereas if you cook rice in tap water, it can cause 8 to 10% loss of thiamine, and cooking in well water may cause a loss up to 36%. Sulfur dioxide rapidly destroys thiamine. For this reason, sulfur dioxide is not permitted as an additive in foods that contain appreciable amounts of thiamine. So if you look at this statement, it shows that different cooking method can give different percentage of thiamine loss. For example, boiling of meat will incur thiamine loss about 15 to 40%. Frying will cause thiamine loss of 40 to 50%, while roasting may incur loss of vitamin B1 or thiamine from 30 to 60%. And this similar to fish. Yeah? So meat and fish are also similar in terms of the thiamine loss during cooking. So storage of whole grain may result in loss of thiamine. However, it still depends on the moisture content. So the higher moisture content, the loss will be higher. And at normal moisture level of 12%, 5 months storage will result in a 12% loss. At 17% moisture, a 30% loss, and at 6% moisture, no loss at all. Meaning to say that the moisture content will greatly influence the loss of the thiamine. The higher moisture content, the higher the loss of the thiamine. Okay, this is another types of vitamin B2, vitamin B, which is vitamin B2, or also known as riboflavin. So this is the structural formula of riboflavin. Aqueous solution of riboflavin, they are yellow with a yellowish green, and they are involved in the oxidation of fatty acids. Very good sources of riboflavin are milk and milk products. Other sources include beef muscle, liver, kidney, poultry, tomatoes, eggs, green vegetable, and also yeast. These are some of the products that contain riboflavin. And if you look at the list here, yeast, dry yeast give you high amount of riboflavin. And from this list, shows that tomato has the least amount of riboflavin. But tomato is higher in carotenoids, carotene, because it is orange in color. Riboflavin is stable to oxygen and acid pH, but is unstable in alkaline medium and is very sensitive to light. And when it is exposed to light, the rate of destruction increases as pH and temperature increases. The light sensitivity of riboflavin result in loss of up to 50% when milk is exposed to sunlight for 2 hours. Eating under neutral or acidic condition does not destroy the vitamin, meaning to say that riboflavin is very stable under neutral and also acidic condition. However, under the influence of light and alkaline pH, riboflavin can be transformed into lumiflavin, and lumiflavin will result in the destruction of ascorbic acid. So, if you are eating riboflavin, but then if this riboflavin has been exposed to light and alkaline pH, in your body, it might be transformed into lumiflavin that will disrupt the ascorbic acid that you have eat. Yeah. Another types of vitamin B is vitamin B6, which is also known as pyridoxine. So there are 3 compounds with vitamin B6 activity, and the structural formula of pyridoxine is like this. So it does have this hydrochloric at the end, because it is exists in hydrochloric form. Yeah. And vitamin B6 plays an important role in the metabolism of amino acid, where it is active in the coenzyme form pyridoxal 5-phosphate. And the recommended allowance for adult has been established at 2 mg per day. And the requirement appears to increase with the consumption of high protein diet. So if you are somebody that wish to build your muscle, so you need to consume high protein diets, and you might consume more than 2 mg of vitamin B6 per day. Vitamin B6 can also exist in another form other than pyridoxine. So it is pyridoxal and also pyridoxamine. So they have this pyridoxal and pyridoxamine have another substituent at carbon number 4 of the benzene ring. And pyridoxal has an aldehyde group, and pyridoxamine has an amine group, methanamine group in the ring. And pyridoxine is stable to heat and destroy alkali or acid. So it is very sensitive to light, and it is rapidly destroyed when exposed to light. And exposure of milk to daylight in clear glass bottle for 8 hours resulted in a vitamin B6 loss of 21%. The term niacin is used in a generic sense for both nicotinic acid and nicotinamide. Okay, this is niacin, this is nicotinic acid, and also nicotinamide. So nicotinic acid has carboxylic group, while nicotinamide has this amide group. And niacin contain in some food can be illustrated by this table. And as you can see, yeast give the highest amount of niacin, while the lowest amount of niacin is found in milk. Nicotinamide act as a component of enzymes which are involved in glycolysis and also fat synthesis. And niacin is probably the most stable of vitamin B, the most stable form of vitamin B. It is unaffected by heat, light, oxygen, acid, or alkali. And the main loss are usually result from the processing, either involve leaching into the processed water. Another type of vitamin B12 is cyanocobalamine, and this vitamin possesses the most complex structure of any vitamin, and it is unique because it has a metallic element which is cobalt. That's why the name is cyanocobalamine. Coba comes from cobalt. This is the structure of the cyanocobalamine. You can see that there is a cobalt metal in the structural formula of this vitamin B12. The most important dietary sources of this vitamin comes from animal products, and only few natural sources are rich in vitamin B12. However, only very small amounts are required in the diet, either 3 micrograms for adults. And good sources of vitamin B12 include meat, liver, fish, and also milk. And table here shows that shows the vitamin B12 content of some food, and you can see that shellfish has lots of vitamin B12. Vitamin B12 is not destroyed to a great extent by cooking. So whenever a liver is boiled in water for 5 minutes, only 8% of vitamin B12 is lost. And even pasteurization causes only a slight destruction of vitamin B12 in milk. So the losses may range from 7 to 10%. Another type of vitamin B is folic acid or folacin. So this is the structural formula of folic acid. Folic acid deficiency is especially likely to occur in pregnant women. It is a requirement of 100 microgram per day during pregnancy and 200 microgram per day during breastfeeding. Okay, folic acid is very useful for pregnant women, and usually when the woman decides to get pregnant, she is advised to consume folic acid 3 months before the pregnancy to avoid spina bifida uh, in their fetus. And citrus fruit and juices are relatively good sources of folic acid. Folic acid is stable to heat in an acid medium but is rapidly destroyed under neutral and alkaline conditions. These are some of the folate content of some food. Okay, lettuce can have a high amount of folate, which is around 2 microgram, but it is still very little compared to the one needed by the pregnant and lactating woman. Another type of vitamin B is pantothenic acid, B5. And this is the structural formula of the pantothenic acid. So our group here is COOH, and R of this pantothenic can be CH2OH, panthenol. Pantothenic acid occurs in all living cells and tissue and therefore found in most food products. And good dietary sources include meats, liver, fruits, vegetable, milk, egg yolk, yeast, whole cereal grains, and also nuts. Okay, this is the table where shows the pantothenic acid content of some foods. This vitamin is stable to air and unstable to heat, but it is stable in solution in the pH range of 5 to 7 and less stable outside this range. Okay, the last type of vitamin B is biotin. So biotin, also known as B7, is important in a number of metabolic reactions, especially in fatty acid synthesis. So biotin occurs in some products in free form, for example, vegetable, milk, and fruits, and in other products is bound to proteins such as organ meat, seeds, and yeast. And good sources of vitamins are meat, liver, milk, egg yolk, yeast, vegetable, and also mushroom. Okay, this table shows content of biotin in some food products. And biotin is deactivated by raw egg white. This is caused by the glycoprotein avidin, and heating of avidin will destroy the inactivated capacity for biotin. So data on the stability of biotin are limited. However, this vitamin appears to be quite stable, while heat retreatment results in relatively small losses of biotin, and pasteurization and sterilization of milk will incur losses around less than 10%. Okay, so this is the end of vitamin B. In this video, I will discuss on the vitamin C, or also known as L-Ascorbic acid. This vitamin occurs in all living tissues where it influences oxidation reaction. The major source of L-ascorbic acid in foods are vegetable and fruits. If you look at this table here, this table summarizes the vitamin C content of some foods. And if you look at the foods listed here, blackcurrant gives you the most of vitamin C, 200 milligram over 100 grams. So if you eat 100 gram of blackcurrant per day, it is actually more than what you should consume per day. Yeah? L-ascorbic acid is readily and reversibly oxidized to dihydroascorbic acid, which retains vitamin C activity. This compound can be further oxidized to diketo L-gulonic acid in a non-reversible reaction. And diketo L-gulonic acid has no biological activity and it is very unstable. So this is the L-ascorbic acid, which can be converted into dihydro L-ascorbic acid, and this dihydro L-ascorbic acid can also be converted into diketo L-gulonic acid, which is a very unstable product. Vitamin C is the least stable of all vitamins and is easily destroyed during processing and storage. And the rate of destruction is increased by the action of metal, especially copper and iron, and by the action of enzyme. That's why in order to preserve vitamin C, we can add sequestrants like ethylene diamine or EDTA, so that it can bind to copper and iron and will reduce the destruction of vitamin C. So vitamin C, upon exposure of oxygen, prolonged heating in the presence of oxygen, and also exposure to lights. So all of these conditions are very harmful to vitamin C because they can destroy the structure of the vitamin C. Vitamin C, enzyme phenolase catalyzes the oxidation of mono and dihydroxyphenols to quinone, and the quinone react directly with the ascorbic acid. And to account for processing and storage losses, it is common to allow for a loss of 7 to 14 mg of ascorbic acid per 100 ml of fruit juice, and light can result in rapid destruction of ascorbic acid in milk, while transparent packaging material permit rapid destruction of vitamin C. So therefore, if we would like to store vitamin C tablets, so we should store them in a bottle which is not transparent to limit the amount of light that can pass through, and then uh, which permit rapid destruction of the vitamin C. So that's all, that's all for learning unit 5 part 2, which is on the vitamins. Yeah. So from the first video, we have already discussed on the um, types of vitamins from vitamin A until vitamin C.